What's up, Geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 10.3, which is how to use chords. So we're going to be able to use chords of circles to find lengths and arc measurements. We do have a few theorems we're going to start off with first. So let's make sure we have our theorem sheet out ready to draw some pictures here. Theorem 10.6 is the congruent corresponding chords theorem. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So we have a picture here, and we can say that arc AB is congruent to arc CD if and only if the segment AB or the chord AB is congruent to chord CD. Okay? The next one we have is theorem 10.7, perpendicular chord bisector theorem. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So we have the diameter EG. This would be a good picture to draw on your theorem sheet as well. And EG is perpendicular to DF. So we see that right angle here, right at point H. Then HD is congruent to HF, and the arc from G to D is congruent from G to F. Okay, so we can even add some congruency measurements here to show that they're congruent. The last one is theorem 10.8, perpendicular chord bisector converse, and that's just going off of theorem 10.7. If one chord of a circle is a perpendicular bisector of another chord, then the first chord is a diameter. So we have here a picture, and it says if QS is a perpendicular bisector of TR, so again we're seeing that 90-degree angle, then QS is a diameter of a circle, such as proving how we know which one is the diameter. Okay? Make sure you have these filled in for your theorem sheet. If you need to rewind, please do that. Otherwise, let's go ahead and try some examples. So, into the diagram, circle P is congruent to circle Q, and FG is congruent to JK. So, and the measurement of arc JK is equal to 80 degrees, so find the measurement of arc FG. This is going to go back to that first theorem we saw, 10.6, congruent corresponding chords. Because we have the same circle or congruent circles, then the two minor arcs will also be congruent. So the measurement of JK arc will be congruent to the measurement of FG's arc. So that is automatically equal to 80 degrees using our theorem of 10.6. Okay? Next up, using the diameter. We're going to try to find HK here, and then find the measurement of the arc HK. I can find HK because this perpendicular bisector is showing that 90-degree angle here, which means HN is automatically the same as NK. So HK would just be equal to HN plus NK. And if NK is 7, so is HN. So 7 plus 7 gives me the measurement of HK, which is 14. Okay, then I want to know the measurement of arc HK. So if we think about that, 11x should be equal to 70 plus x, and again that's going back to our perpendicular chord bisector theorem, where it's creating corresponding arcs. So all I need to do now is just to solve for x. So I'm going to subtract, get all my x's on the left side, so 10x is equal to 70. That means x is equal to 7. So the measurement of HK is just 11 times x, or 11 times 7 plus another 77. That's going to give us 154 degrees. Okay. Next up, we have a word problem with some application of a garden. We're actually going to skip this one for now, and we'll come back to it at a later date. But we're going to go ahead and look at this one. So this would be a good idea. If you haven't tried any questions on your own, let's go ahead and pause the video here, Try these on your own, and when you're ready to check it, click play. All right. Once we've tried it on our own, let's see what happens. If the measure of AB is equal to 110 degrees, so we're looking at these right here. Okay. What can we do to find the measurement of BC? Okay, so BC is going to match whatever mark of AB is, just because we're seeing that segment with the chord. So the measurement of BC is also equal to 110 degrees. If the measurement of AC is equal to 150 degrees, find the measurement of AB. So here's AC, okay, and AC, if that's 150 degrees, then what I could do first is maybe take the rest of it, because AC would be all the way around. So all the way around would be 360, so minus 150, and then AC, AB is just half of that, so then I'd take that number and divide it by 2. I'm going to come up with 105 degrees. Okay. Now in exercises 3 and 4, we're going to use this one. So in exercises 3 and 4, find the indicated length or arc measure. Again, this would be a good one to try on your own, so if you can, go ahead and pause the video here and then click play when you're ready to check your work. So CE is showing that perpendicular bisector, so that means both of these are equal to one another. So for number 3, the CE measurement, I'm going to say 9x is equal to 80 minus x. Start by getting x to one side, so 10x is equal to 80, which means x is equal to 8. So CE, we can even just say 9 times 8, which is 72. So this one would also be 72. So C to E, oops, I measured the arc, so we're doing technically number 4 here. C to E would be 144 degrees. CE is a chord, and if this is 5, that means my perpendicular bisector is making a congruent C statement. CF is equal to FE, so together they make 10. Okay. Next theorem we have, and this will be our last theorem we discuss in these notes, 10.9 is the equidistant chords theorem. In the same circle or congruent circles, 2 chords are congruent if and only if they are equidistant from the center. So again, this is a good picture to draw, and we are wanting just to prove if chords are congruent. So the chord AB can be congruent to chord CD if and only if EF, which is this line here, is equal to EG. So that would be a good picture to draw for your theorem sheet. When you're ready, go ahead and click play so we can try some examples together. So in this diagram we have QR is equal to ST. So that is showing me that both of those chords are the same and they're equal to 16. Okay? Which also means this perpendicular bisector is creating 2 lengths of 8, right? So ST, this one is not having that perpendicular bisector, so I can't say that about ST yet. Then CV, which is here, is that 5x minus 9, already labeled. Find the radius of circle C. So what I want to basically understand is, because I have 2 congruent chords, that means this equidistant 2x and 5x minus 9 are equal to one another. So let's start with that. 2x is equal to 5x minus 9. I'm going to subtract 5x from both sides. We get negative 3x equals negative 9, so x is equal to 3. Then I want to maybe think about my radius is exactly half. So from here, how much would that be equal to? Okay, so we're even looking at possibly making a right triangle here. So your radius can be found by maybe going from C to Q, and this is creating that right triangle. So I'm going to just enlarge that real quick. So here's point C, here's point Q. We already know this is 8, here's point U, and then 2 times x, or 2 times 3 is 6. So we're just trying to figure out what this guy is. Then this will tell us what our radius is, because it's going from point C to point Q, so that's the center to the edge. So we would just have 6 squared plus 8 squared, so we got our right triangle here, is equal to, we'll go ahead and say that's r squared because we're solving for r. So 36 plus 64 equals r squared. Popular trio here. 100 is equal to r squared, so r equals 10. Okay, so that was kind of think outside the box question. One more, this would be a good one to pause and try on your own. So just like we did before, try this one, see what you come up with, and when you're ready to check, click play. All right, JK is equal to LM here, and those are both equal to 24. For JK, because this is equal to 24, that means JP and PK are equal because we have that perpendicular bisector, so both of these are simplified to 12. And then NP is 3x, and NQ is 7x minus 12. Because we have two congruent chords, those are equidistant, so that means 3x is equal to 7x minus 12. I'm going to go ahead and subtract 7x from both sides, so I get negative 4x equals negative 12, which just means x is equal to 3. So now what I want to do is I want to find the radius of circle N, and one way to do that is to connect N to K. So now I create this right angle. 3x is just 3 times 3, which is 9. I have a 12, and then I don't know my radius, which is r. So 9 squared plus 12 squared equals r squared, or 81 plus 144, which is 225 equals r squared. So r has to be 15. Okay? That'll conclude our notes today on lesson 10.3, using chords. Hopefully this video helped you, and if it did, give it a thumbs up. Thanks again for tuning in, and we will catch you next time when we talk about inscribing angles in polygons and circles. Have a great day.